My name is Kip Solomon. I'm a professor at the University of Utah in Salt Lake City in the United States. I study groundwater, and in particular I study the residence time of groundwater. I've come to Azul to give a short course on dating groundwater. Most of the fresh water that's usable in the world is groundwater. We have lots of water on this planet, but most of it is salty. We have a lot of fresh water in ice, but the next largest reservoir and the largest reservoir of usable water is in the ground. But it's really difficult to understand how water moves in the ground. The properties that control the rate of groundwater movement are so variable that it's very difficult to understand groundwater systems. One of the best techniques that we have is to measure the isotopic composition of this water, especially with isotopes that can tell us the age of the water. And if we know the age of the water, we can calculate how fast it's moving, how much is recharging. We can evaluate the quantity of water that's in the subsurface. So in the past few days, we collected groundwater samples from various depths in the subsurface, and we're going to measure tritium, which is a radioactive form of hydrogen that's just present in water. We're going to measure the daughter of tritium decay, which is helium-3, and with those two we can estimate the age of the water. We're also going to measure sulfur hexafluoride and chlorofluorocarbons, and we're going to use these also for dating the water. If we can find out how old it is at this depth and then how old it is at this depth, we can determine the downward velocity, which is related to the recharge rate.